So now we talked actually about that what are sockets, right? I mentioned that on the server side we'll be creating a new socket object, right? And on the client side as well, we'll be having a socket object, and these socket objects are going to actually connect with each other and actually will be trying to you can say communicate, right? So let's say I'll create a new Java class and I'll call it as server. Okay, so I'll be writing a server class kind of a thing. You can see basic class server, right? And inside this, let's say we'll be having a main method, right? If you don't know about Java, this main method actually starts executing stuff. Once you have once you actually run a Java file, the first function that executes is the main method. Okay, so inside this main method, let's say I'll mention a port variable. So let's say I'll say port 8080. Okay, the port variable is, let's say, 8080, and I'll do one thing. I believe I should do it. um I'll increase the font size in a moment, just a second. Yeah, that should be good. Okay, cool. So I'll create a port variable here, int port 8080. Just it is a variable that is storing some port number, right? And then what I'm going to do is, in Java we have a server socket class, right? So what we can do is we can try to actually create a new server socket. So there is a library called as java.net. From java.net you can see there is a class server socket. What I'll do is I will try to create a new server socket object. This is going to actually, why server socket? Because server socket has the responsibility that it will start listening to a new socket connection and start accepting a new socket connection. What do you mean by accepting a new socket connection? That means that multiple clients will be able to actually connect to this socket, right? So we'll say new server socket. Okay, and we will have to pass the port number. Okay, right, you can see we have to actually pass the port number. Okay, cool. Let's see why this is throwing an error. Cool, and we have to actually add an exception. Okay, throws IO exception. Cool, and we can actually catch that exception here as well. Catch IO exception ex, right? Will print. So in Java you print something like this: system.out.println. Okay, server exception. So in case we are not able to create a new server socket object, so this error is going to be thrown. So I'll say ex dot get message, right? And we'll say ex dot print stack trace. Okay, and then what we are going to do is we'll first of all say, if you are able to create a new server socket object, so we'll say server is listening at port, you can say, for the given port. Okay, and then now you can see we have created a brand new server socket object. Okay, this is plain, fair and simple. So if I try to run this code, you can see it says server is listening at port 8080, right? You can actually see that, right? Now it just created a server socket object. Now what do we have to do is we have to start listening to, like, we are already having this port server running at port 8080. Now what do we need to do is we need to start accepting new connections. So we'll say while true, I'll keep a infinite loop going on, and I'll say socket, right? Socket. So now a new socket connections from comes from a socket object, right? This was server socket. Now this is just a socket connection, is equals to new socket, or you can say is equals to server socket dot accept. Okay, so you can see the server socket is going to start accepting new connections. The moment it accepts a new connections, you'll say system dot out dot println new client connected. Once new client has been connected, right, then what do? You actually do new client handler, right? And you actually pass the socket object and you call the start method out of it. Okay. So I'll also just do one thing. I'll just import java.net.start, everything from java.net. We are going to actually just quickly import, right? And from IO also, we are going to import everything, right? Cool. Now you can see this says new client handler and it accepts a socket connection and calls the dot start method. There is no client handler class as of now. So we can actually create a client handler. So till now what we have actually done is that we just create a new server socket object which is listening on port 8080 of my own machine, right? And then we start accepting new socket connections. And once we have a new socket connection, we actually create a new client handler object, right? Let's see what happens in client handler. Okay. So I'll create a new file. Okay, client handler. And now you can see this has been actually resolved. Now this client handler is going to accept a socket object. So I'll say private socket. And there will be a constructor. So how do we write constructor in Java? Public client handler. This is the constructor. I'll pass a socket object and we can say this dot socket is equals to socket, very much similar to what you actually do in JavaScript, right? And then there will be a, let's say, public void run method, right? So inside this run method, we will be writing all of our logic to what should actually happen, right? And technically this should be, let's say, dot run, right? Kind of like a run method. Now what should happen in the run method? Let's try to do that. Okay. So let's say we'll be having a string text is equals to some text. Okay. And what we are going to do is we will say system.out.println received message from client text. Okay, so this is the message that is going to be sent from the client. Okay, so what now we are going to do is we can actually simulate a kind of like a delay that every 1 second we are sending something. Okay, so let's wrap it in a do while loop. So there's a do while loop just like JavaScript as well. Okay, and you can say do while, right? And let's do one thing. I'll say int count equals to 0 while count is less than 10. Okay, we are going to do this every time. We'll do count plus plus. Okay, and let's bring all of this here. Let's paste it here. Okay, now what we are going to do, we are going to simulate a delay. So there is a thread class that can actually have a sleep method and we can have a delay of 1000 milliseconds, right? And we need to actually catch an exception, that is interrupted exception ex. Okay, we'll say copy thread interrupted. Okay, cool. Ex, sorry, plus ex dot message. Okay, cool. Okay, and then what we are going to do is we'll say system dot out dot println thanks. Okay, that's it. That's what we are going to actually do, right? We'll keep on repeating this loop. At last we are going to actually close the socket connection. Okay, so we'll say socket dot close, right? This looks good, and you can say this dot socket dot close, right? Let us see why we have this issue. We will add an exception, right? This throws our exception. Cool. So now you can see we have our client handler also ready. So I'll just walk you through that whatever I wrote. This is just a simple server. What this server is actually doing is it creates a server socket. Once we have the server socket actually created in front of us, right? what we are actually going to do is we are going to start accepting new client connections, right? In new client connection, you call server socket.accept so that a new client gets connected on port 8080. You'll say new client connected, and then you're going to create a new client handler object, right? Pass this socket object, right? That you actually created. How did you create it? By creating a new socket connection. Okay. And then on that socket, we are going to call a run method, right? You can see we are going to call a run method. Now you can see what happens in the run method. There is a text, some text. There is a count which runs this loop for, let's say, 5 times instead of 10. Let's go 5 times. Every time, what do? You do count plus plus. You say received a message from client. You do a delay of 1 second, and after 1 second, you just print thanks. And then you close the socket connection. So every client that you're going to connect, what it is going to do is it's going to keep on sending you some kind of a thanks. Okay, this is good. Now let's do one thing, right? Let's keep a count here as well. Int count is equals to 0. Okay, and let's say new client connected, comma count is, let's print a count here, right? And let's do one thing. This run method, let's say, also accepts a count. This run method accepts a int count. Okay, so some text from client, I would say count, received message from client, right? This, and let's say this is just C and C. Thanks count, that is which client number you're thanksing. Received message from client count. Okay, something like this. Okay, let's say something like this. Let's try to now run the code and let's see what actually do we get. If I run the code, you can see server is listening at port 8080. Okay, and now you can see the code has not stopped yet, right? This code is actually not stopping, right? You can see there is no play button and there is a pause button here. If I click here, that's when the server actually stops. If I run again, you can see the server is listening. So what's happening is this now function is not ending because it's running in a while loop, but it's waiting for a socket connection because you can see there has not been any client that has yet connected. Can I say that? So now we have our server in place. You can actually see that. And once a new client will connect, then what should happen? Then client handler.run should work. But you can see there is no client connection that we are initiating. If you remember, what do we have to do? Client has to initiate a connection, right? It will not automatically initiate a connection. That means what do we need to do is we need to write a new Java class client. Okay. We need to write a new client Java class. Okay. And let's say there will be again a main method here as well. I'll say string host name is equals to localhost because client needs to know where to connect, which address to connect and which port to connect, right? Port is going to be again 8080 that we are going to connect to. Okay. And now client is again going to create a brand new socket object. So we'll say socket is equals to new socket, right? And we are going to pass a host name and a port. You can see that. Okay, a host name and a port, and we'll add a catch here as well, right? So which exception we are going to say unknown host exception ex. Either this will be catched or let's say IO exception will be catched. Okay, cool. I'll write the implementation inside catch. I'll just copy paste it from here. Copy, paste. Cool. Okay. Let's write our main try logic. So now we have our socket created, right? Once we have the socket connection created, you can see the client is going to create a brand new socket object. If you remember, I talked about the fact that client has to initiate a socket connection to this host name and port. Server has its own socket object. client has its own socket object, and now these two socket objects are going to communicate with each other. So first things first, we should say hello server, right? We are going to say hello server. That's it. Okay. And then what do we have to do is, let's see. So, or yeah, let's just do this much. Let's just do this much. Okay. So now you can see server is already running at port 8080. This file is already running. Let's say I will run my client code. Let's say I will run my client code. Okay. So I'll play this client code from here. And you can see it created a brand new hello server. Let's see if something happened on the server. You can see no, nothing actually happened on the server, right? So what we are going to do is we have created a brand new socket connection, but now we are going to first of all try to send some data to the server, right? If you don't understand how we are actually sending the data to the server, just hang on with me. It's a bunch of Java syntax that you have to actually do. So there is something called as a print writer class that you have to actually create, right? That is, let's say out new print writer. This will take something called as a, so inside the socket object there will be a output stream that we have to get, right? And we'll pass auto flush flag as true, and we'll say out dot println hello server. Okay, we'll remove this, and then we'll actually create something called as a buffered reader input as new buffered reader, right? And here I will pass new input stream reader, and we'll start reading the input from the socket connection. So socket dot get input stream. Okay. And then what we are going to do is we'll say string response is equals to in dot read line, and we'll say system dot out dot println server response is response. Okay, let's try with this. Okay, so now you can see server is running behind the scenes. If now I try to run the client code, okay, so you can see it says server response HTTP 1.1 400 bad request, right? And if you go to server, you can see nothing actually happened on the server. Okay, so on the server side we should do one more thing. On the server side we should do one more thing, right? Instead of just printing what we are getting on the client, let's do one thing. Okay, let's do one thing. So I'll remove this. Okay, we'll create a new socket object. We'll just say system.out.print new client connected. Okay, new client connected, and then what we will do is we'll try to read it with the same way of buffered reader, the way we are reading there, right? So this is all like mainly for Java. You don't have to do it in let's say JavaScript or anything, right? So you can say socket dot get input stream catch, right? We'll say IO exception ex. Okay, cool. And then we'll say we'll create a print writer again out. This is to mainly print what we are receiving on the other end. Socket dot get output stream, right? String client message is equals to en dot read line. So we are going to read the client message. We'll say system dot out dot print message from client. Okay, what is the message from client? Client message. Okay, this is good. And we'll say out dot println server or echo from server client message. Okay, so we are going to do this, right? Let's try now. So let's restart our server. Okay, so server is listening at port 80. Let's try with the client again. So this is the client file. Let's run the client file. Okay, this is still not connecting. So I just played with one thing. I changed the port number. So I guess on port 8080 something is already running on my machine. Right, now you can actually see that if I rerun the code, one second, let me run the server file. So you can see I initiated the server, and you can see now the moment I try to run my client file, you can see we are receiving some response from the server. And on the server side, you can see a new client connection is created, and the message from the client is hello server, right? So you can see that here. You can see message from the client is hello server, right? Something like this. And if you try to run multiple times, for example, let's say I create a new client connection again, one more, right? So you can see another client connection got created, right? So what's happening is that there is a socket object which has your host name and the port on the server side. You can see on the server side we have a socket object, right? On the client side as well we have a socket object. This socket object again has your host name and port. The server side doesn't need the host name because the machine you are booting up your server on, it will consider that machine host name only. And now it has starting to accept a new server socket connection, right? So the moment a new client initiates a socket connection, what happens is this server socket dot accept call gets executed. When you write a while true or an infinite while loop like this, it's not like it's creating new connections, new connection, new connection. No, it's waiting here on line number 10. It's waiting to actually accept a new connection. The moment you create a new connection, this accept call fulfills, and then you print new client created. And then you say message from the client is client message, right? And you can see if you go to the client, the message from the client is hello server, right? So that's how actually things are communicating. So this is how you actually create new socket objects between the client and the server. And all of this actually goes behind the scenes. So the moment you actually have any kind of a, you can say, web server or anything that you write, internally, if you are using a framework, then that framework internally is actually creating all of these socket objects, right? So this is actually important because otherwise there won't be a way that via the network you are able to communicate from your code, right? You need these socket objects on both the ends so that you are able to actually communicate with different clients at the same point of time. Now, whatever we actually discussed about socket programming, what I'm going to do is I'm going to create a basic server, which is going to create a new socket object. And I'm going to create a client that is going to connect to that socket object. It's very easy to do it in Python. So in Python, you have a library called as socket, right? So we're going to import that library socket. We'll say print starting a new server. Okay, save it. I'll just quickly run it to see if everything is good to go. Sorry, we should run it from Python 3 server.py. Okay, you can say starting a new server. That means this library import and everything is working. Cool. Now, what we're going to do is this library, this socket library, actually provides us access to a bunch of method. One of the method that we can use to create a server socket object is socket.socket. Okay. This method, this socket method, what it is going to do is it is going to allow us to create a brand new server socket object. So this is the official documentation from the socket library that Python is actually providing us, right? You can see it's a low living networking interface, right? This module provides you access to the socket interface. It is available to run on Windows, Mac, Linux, all kind of systems. Okay, cool. So let's see. So if you are creating a socket, you can see I have used a socket.socket method. Can you see? There is a class socket.socket. This actually creates a new socket for you on the given address, family, and socket type and protocol number. So you can see it's expecting a lot of things from us. It is expecting an address. It's expecting a family. We'll talk about what's that family. It's expecting a socket type for us, and it's expecting a protocol number. Okay, so let's actually talk about all of these things. Okay, so what's this family, right? The address family should be AF underscore INET, the default, or INET 6 or AF Unix, and so on. So what is this? This is actually telling that what type of a IP address we are actually looking at. Are we trying to connect to IPv4 or an IPv6? If you try to read about AF underscore INET, Okay, you can see it's kind of like an enum. These contains, so these constants represents the address families used for first argument of the socket method, right? The AF Unix constant is not defined, then this protocol is unsupported. More constants may be available, right? So if you actually read more about, uh, you can say AF underscore inet, AF underscore inet socket Python, right? So AFINET is the internet address family for IPv4. So there are two type of IP addresses, IPv4 and IPv6. So INET is for IPv4, INET6 is for IPv6. Okay, so what type of IP address you are actually connecting to? Then there is a socket type. If you see the socket type, there is a sock stream that is the default type. If you want to change, then this is the sock dgram or sock raw and everything. What is the sock stream? If you actually open about sock stream, right? And if you actually Google for sock stream, this is for your TCP connection. Okay, this is for your TCP connection. The sock dgram, if you pass sock dgram, this is for a UDP connection, right? You can see this is for a datagram based protocol, that is a user datagram protocol. So what type of a protocol or what type of a underlying transport layer, I would say, interaction you want to do is given by the I would say socket type, right? And then you have the address and the I would say port number and everything. That's basically simple, right? So this is what actually happens. So we don't need to pass anything because we are going to expect all the default parameters. That is, we want a TCP connection and we want it over IPv4, right? Now you can see we have actually created a socket, object. Okay, now this socket object needs to actually bind to a particular port and a host, right? So let's say we will say host is localhost and port is, let's say, 8082. Okay, and then what we are going to do, we are going to bind to a port. How do we bind to the port? Very simple. There is a dot bind method that you can provide, and it expects kind of like a tuple. So this kind of a syntax it expects host comma port. So let's see about the bind. There's a bind method, right? Or functions. So this is the socket method, and socket pair, create connection, create server, right? Let's see other functions, close, get address info, and socket dot bind. You can see socket dot bind. So this binds the socket to the given address. That is the address and the port. The socket must not be already bound. So if the socket is already bound to address, then it will not work, right? See, this is what the bind method is actually going to do. And using these two actually library calls, we are able to not only just create a brand new server, but we are also able to connect, or you can say bind it to a port, right? Then there is a socket.listen method. You can see now the object has been created, but that's not enough. To enable a server to accept connections, we need to start listening that, okay, now the server is up and running and I'm listening to incoming connections from the client, right? So you can say we'll be doing server socket.listen. Okay, that is listen for incoming requests. Okay, that's the server socket.listen. So this socket has started to listen for a bunch of requests. Okay, cool. Now we can say, we can actually print here, print, you can say server is listening on host comma port. Okay, cool. If I run this code, you can see it says starting a new server, server is listening on localhost 8082. But you can see it immediately stops and does nothing. Why? Because we have created a server object, or you can say socket server object. We have not established any connection, right? You have a socket object lying in your memory. Now what client will do, it will initiate its own socket object, and with its own client socket object, it will initiate a connection, right? So for that connection, we have to start accepting a new connection, just like how we were doing earlier, right? Accepting new connections, right? In the Java interface as well, we had something like this only. If you see dot accept, we have to start accepting. So this is going to be a, I would say, a blocking call, right? This accept is going to be a blocking call. So you can say server socket dot accept, save it. And now if you run it, can you see now this is a blocking call. On line number 20, your code is blocked. It's not moving forward because now it is expecting a connection request from somewhere. And once a connection request will come up, it is going to accept that connection request. You can see now the code is not stopping. So if you read about the accept method, you can see it accepts a connection. The socket must be bound to an address and listening for connection. So you can see the bind call should be done and the listen call should be done before this. This returns two things. One is a connection object and one is an address. So you can see connection is a new socket object usable. So it's a new socket connection object which will be used to send and receive data. So one server socket will be having multiple socket connections to different clients, right? Something like this. So let's say if you have one server, on one server, different clients are going to one by one connect. Can I say that? Different clients are going to one by one connect, right? So one server socket is going to accept multiple client connections. So when you do server socket dot accept, it actually returns you a connection object and it returns you an address, right? These two parameters actually it does return, right? This is something cool. So now what we can do is we can say print connection established. Okay, connection established. Okay, so let's say to establish a connection, I will just quickly write a client as well, client.py. Okay, similar thing we are going to do there. Now client is also going to have a host and a port. This time this port is the same port as that of a server port because we have to connect to a corresponding server, right? We will create a socket connection and this time it will be a client socket. So I'll name it as a client socket. Okay, and now you don't need to bind or anything. Once you have a client that has a new socket object, the client is going to initiate a dot connect method to the given host and a port, right? Clients can also connect to multiple servers, right? So let's say wherever our server is on localhost 8082, this particular server we are going to connect to, right? So let's see. So we'll restart. So you can see server is running on this and I'll have one more terminal up, right? Here I will say Python 3 client.py. You can see it says starting a new server on client.py because it was saying starting a new server. And if you go here, can you see the server code has now stopped? It was waiting to listen on this port and it established a connection and you can see it printed connection established. The moment it printed connection established, now that blocking call is done, there is nothing more else left in the code and you can see we have dropped it here. Can I say that? Right. Cool. Now we can even exchange data between the client and the server, right? So what you can do is data incoming is equals to, now on the connection object, you can start receiving. Okay. So there is a receive method. You can see receive method. This receives data from the socket. So whatever is your socket connection, it will start receiving the data. The return value is a bytes object representing data received. The maximum amount of the data that can be received at once is the buffer size. So you have to pass a buffer size that how much amount of the data you want to actually receive. So let's say I'll pass 2048 as the buffer size. Okay. And then we are going to say print data received from client as data incoming. Okay. Cool. Now let's do one thing. At last, we'll do connection.close. Okay. So let's say we have received the data from the client. We are going to close the connection. And after closing the connection, we can also do server socket.close. We'll also close the socket object. Okay. It's a good practice so that you don't have any open ends left anywhere. Right. Cool. Now on the client, let's say from the client, we are going to start sending some data, right? We have connected from the client, right? Now let's start sending some data from the client. So we can say client socket. So there is a method called as send all. Okay, there is a method called as send all. And let's say we'll send hello server. Okay, hello server. Cool. Let's see now what happens. So let's turn up the server. So you can see server is again blocked on a receive call that is expecting. Python 3 client.py. Okay, there is an error. Oh, it's a byte that we have to pass. So it's a byte string. So how do you pass a byte string? You just prepend it with a B. Right. So let's restart. And you can see starting a new server. And on the server side, can you see it is receiving some data from a client? Can you see that? Right. We have started receiving data from the client. And in fact, the server can also respond back. So once you have received the data from the client, what you can do, the server can also send the data. So I'll say send all. Again, a byte string. I have received data from you. Okay. And if the server is actually sending the data, the client can also expect to have that kind of a data, right? So client will also expect that there is a incoming data coming from the server, right? So let's do one thing on the client side as well. We'll say response from server is equals to client socket dot. It will also receive. How do we receive? RECV. We'll say 2048 byte, let's say. And then we can actually say print response from server. Let's try. So now let's turn up the server, turn up the client, and you can see now the client is also receiving the data from the server, right? How cool is that? This is what we wanted, right? This is what we wanted. And let's do one thing. So there is a time library that we can do. So let's say once we receive the data from the client, no, let's do time.sleep, right? Of let's say this, right? I guess it's a second that it expects. So time.sleep in Python. Okay, let's read about it. Yeah, t seconds. So let's say now what we are going to do, we are going to wait for on line number 28 for 10 odd seconds. Before 10 seconds complete, the remaining code will not execute because in Python it executes everything by line by line. So this will be a blocking call here. Okay. So let's see. 1 second. Oh my bad. So you can see now the server is expecting a connection from the client. So this is on line number 20. So it's waiting on line number 20. Now on the client, you can see I have started a new connection. You can see the server has received the data from the client and server is processing for 10 seconds. You can see client is also waiting for the data from the server. And after 10 seconds, client receives the data from the server. Can you see that? Right? This is cool, right? So if server takes some response, so client is going to wait. So that socket connection is going to be there, right? It's not like just sending some data like a function call. So that socket connection is actually present there, right? Once all of this is done, like this time.sleep is done, then server is sending back some response, client is actually receiving it. Now let's say I'll create a new file, client2.py. I'll copy everything from client in client2.py. We'll say hello server. This is client2. Okay. Right. So you can see now we have another client starting a new server for client2. Okay. Let's see now what happens. So now I have two clients. Okay. I have two clients. I'll turn up the server again and I'll increase the sleep time of server. Let's say server takes 20 seconds to process. So I'll turn up the server. Now what I'll do is Okay, one second. One second. What happened to the display here? Okay, okay, cool. Okay, so let's say I'll turn up the server again. So our server is up. Now I'll say Python 3 client.py. So this client is sending a request. Python 3 client 2.py. And you can see client 2.py. And let's see what happens. Now both of them have started actually to send the data, right? Both of them have started actually to send the data, right? And can you see server just received the data, hello server. It didn't receive the data, hello server from client 2. That should not technically happen, right? Every client should be able to connect to the server, right? Client 1 should be able to connect to the server. Client 2 should be able to connect to the server. But the problem is currently the server code is running on a single thread. This is the main thread. And this time.sleep or this connection is actually blocking the main thread, right? This is actually blocking the main thread. So what should ideally happen is we should spawn up multiple threads. We should technically spawn up multiple threads. And once we have multiple threads in place, right, what we should technically do is every new connection object should be prepared on a new thread. That is something that we should technically do, right? So let's try to do that. Let's try to do that. So I'll say, once listening and binding is done, this particular part, this should technically happen, let's say kind of like in a while loop. So in a similar while loop that I did in the Java code. So I'll say while true. Okay. Okay, while true. Cool. So first things first, we are going to accept a new socket connection. Once you're going to accept a new socket connection, what we are going to do is I'm going to use the threading library. It's very easy to spawn up a thread in Python threading. Okay. And then what I'm going to do is I'm going to, let's say, write a new method. Let's say I'll write a new method. So how do you write a method in Python? You write it like def. Instead of saying function, you write def. Connect a client. Okay. Connect a client. Okay. This connect a client method is going to expect a connection object and an address. How do we get the connection and the address? You can see when you connect to a client, right? It will give you a connection and an address, right? Once you have access to the connection and the address, what do you do is we'll say print new client connection established, right? Okay. Then data is equals to connection dot receive 2048 print data from client is data. Time dot sleep, let's say we'll sleep for 10 seconds. We'll say connection dot send all as I'll say the same thing, this one. Okay. And then connection dot close. Okay, looks good. Remove this. And now all of these calls can be removed. So you can see we were also doing the same thing. We were receiving some data and then after 20 seconds or 10 seconds, we got sending some data. So now technically what we should do is we should call this method, right? We should call this method and pass connection and address. But we should call this method on a new thread, right? So how do you call this method on a new thread? You can say threading dot thread. It will initiate a new thread, right? Which method to call? So there is a target parameter that takes the callback of which method to call. So I'll say connect to a client. And then you have to mention what arguments you need to pass. So I'll pass the connection object and the address. Okay. And this returns you a brand new thread. This returns you a thread T. Okay. Then what do? You say t.start. You start a new thread. Now what will happen is if multiple clients will connect, you know, this is a blocking call, right? My while loop will start. This will be a blocking call. I'll be blocked. The moment a client connects, this call will be executed. We'll spawn up a new thread and we'll start communicating to a client on a new thread. And I'll say t.start. and then while loop executes again, and we are going to block again, right? Let's try. Okay, so I'll would like to do it on my terminal. That way I believe I'll be more fast here. Okay. So I'll open 3 tabs. Okay, and let's do one thing. Okay, this tab is here, and let's bring this tab here. Okay, cool. Let's clear everything. So now I have 3 tabs. Okay, so I have 3 tabs here. Cool. So on this tab, what I'm going to do, I'll say Python 3 server.py. Okay, you can see server is listening and it is waiting for a connection. I'll say Python 3 client.py. Now you can see a new client connection has been initiated, and parallelly I will initiate another client connection. See, client 1 and client 2 both has got a new connection. They are waiting for a response. After 10 seconds, you can see this received a response. Let's wait. Will this receive a response or not? Yes, you can see this also received a response. And the server is still up. The server is still up. You can again initiate a new client connection. You can see more client connections I'm able to initiate. Can you see that? Right? So that's how socket works. That's how socket works. So to technically to send the data and receive the data over the network, you need this kind of an interface, right? So that it defines, okay, on what protocol you are going to connect, right? And how you are going to send the data. You can see how we are sending the data from server to client. This is the call which is sending the data from server to client. How we are sending the data from client to server. This is the call that is sending the data from client to server, right? So whenever you use any modern framework like Rails, Express or anything, all of these internal details are actually hidden, right? You can just turn up the server and automatically it handles creation of the socket connection and everything. Let's say you have an Exaios call from your React, I would say code, creation of socket object there on the client side, everything. This is all kind of like abstracted for you. You just directly use it. But what's going under the hood? This is going under the hood. This is actually going under the hood. So I'll just quickly commit all of this. Okay. So it's good. And I'll create a new GitHub repo. So in Python, it's relatively very easy to understand everything. Here we go. So if you go to my repository of socket programming, you will get all of the Python code here. So if I show you this Express.js code, right, like how you actually create a new web server with Express.js, it's like all fairy tale that, okay, oh, you do app.listen port and it start listening and all the requests are incoming. Behind the scenes, all of the things that I mentioned to you is actually going on, right? So always it's good to actually understand the internals of how things are done, how a particular type of code is actually getting executed, what's the logic behind whatever you're doing, why you are doing. This actually helps you to get more internal insights on understanding things better, I believe. And again, similar thing you can actually do with JavaScript as well. Like I would like to put some JavaScript code in place as well. So now in JavaScript, like in the Node.js runtime, we have a net, I would say, module that can actually help us to do similar kind of a socket programming, right? If you carefully remember in our last Python example, you can see that on the server side, in order to cater multiple client incoming requests, we are running all those requests in a different separate thread altogether, right? But now you might be thinking that how we would be able to do it in JavaScript, because JavaScript doesn't have any kind of threads, right? So how the parallel execution, like let's say multiple client requests actually come up, how those requests are going to be actually catered, right? So in JavaScript, we already know that in order to have situations like these for asynchronous programming, we already have event loop and the queues. And apart from that, to handle multiple concurrent requests, we have a dedicated thread pool that is given to us by libuv. So all those mechanisms are already set up in Node.js, right? So we don't have to bother a lot. So what I'm going to do is in the same folder, what I'll do is I'll write a new file, node server.js. Okay, so what we are going to do is we are going to actually require our net library. So don't worry if you don't understand the syntax, I'll come to it. So we'll say const net is equals to require net. Okay, and then this net module actually help us to create a new server, right? So what you can actually do is you can say const server is equals to net dot create server. So there is a method called as create server which expects a callback. Okay, right? And it returns us a server object. This server object you have to actually start listening, just like how we were listening to our server object here. You can actually see we were started to listening. We'll start listening here as well. And here also we have to mention a port. So let's say the port that I'm going to mention is 8083. Okay, and you can give a callback. So once the server successfully starts, after it starts, like you will start listening to port 8083, right? So once the server is booted up, so this is how you create the server. Once the server is booted up and starts listening to incoming requests, incoming socket connections on 8083, this callback is executed. So we'll say console.log new server up on port 8083. Okay, cool. And now when you are creating this server, so you call the net.create server method, it expects a callback. Inside this callback, you get access to a socket object. And you can do now all of your socket programming here, right? So you can say that now, because it's an event driven, now in JavaScript, it's an event driven programming that when the client is going to initiate a new socket connection and send the data, then we have to do something. So it's an event. So there is a syntax like socket.on, and you can say data, and it is going to give you the data that is incoming. So you can say console.log data received from client. What data you have received from the client? You'll say data dot to string. It's a binary data most probably that comes up, so we'll convert that to a string. Okay, and let's say once we have it, we can also write like a kind of like a request from I would say, or data send a data from the server. How do you do that? You can say socket.write. The moment you do socket.write, it sends that data from the server. I'll say hello from server. Okay, something like this can actually work, right? Now we already have a client that is written for us in Python. Okay, so let's say in the client I'll change the port to 8083 and let's try to run it. Okay, let's try to run it. So I'll stop the Python server and instead I'll execute the node server. So I'll say node server.js. So you can see the server is up on port 8083, but no client has connected yet. So let's try to connect this client, python3 client.py. And can you see it started a new server and it received hello from server. And you can see it has received their hello server. And let's say if we say hello from node server, let's write it like this, hello from node server. Let's restart the server. And if I make a connection request from client, can you see it is receiving hello from node server. So our client is written in Python, our server is written in Node, and still see everything is working fine. So it's not like a Python client can only interact with the Python server or a Java client will only interact with the Java server. That's not how it works, right? And let's say in case you want to create a client also in Node, so you can say node client, right? And you can use the same net module, right? So what do? You create a new client. How do you create a new client? You do net.create connection. Okay. So just like in Python, you do socket.connect. Here you do create connection. It's like just JavaScript syntax here. Okay. And then you pass an object mentioning the port as, let's say, 8083, right? And you get a callback. Inside this callback, you'll say console.log. Once the connection is established, you can say client connected. And once the client is connected, you can send some data from the client. So you can say client.write hello from node client. Okay. This is how you can actually create a new client connection. So let's try this. So let's say I restart my node server, and now let's say I'll execute the node client. So can you see we are getting client connected, and what data this client is sending to the node server? Hello from node client, right? And let's say now client, because you can see the node server is also sending the data, right? This is from node server that is sending to the client. So how do we do that? We'll say client dot on data. So if you receive data here, right? Again, similar kind of a data callback we are going to get, and we'll say console.log data.toString. Okay, something like this. Okay. So if now let's say you restart your node client, now can you see you are able to receive the data from the node server as well. As simple as that, right? So writing again a socket just like this is going to be pretty simple. You can initiate one more node client connection, right? You can see one more connection is received on the server end, right? So multiple connections, how JavaScript is handling due to the existence of the thread pool and the whole mechanism of the event loop and the, I would say, whole asynchronous programming architecture that we have in JavaScript. But I believe the overall socket programming part, that if there is some data interaction that is going to happen on the network, how sockets are going to be actually set up is clear to everyone. We have done it in Java, we tried it in Python, we tried it in Node, and you can see the one in Node is the most simple one as well. So just to revise how we did it in JavaScript. So there is a module that we have available already in the Node.js runtime, that is the net module. This net module actually helps you to create a socket server using the create server method, right? And returns your socket server. Then you can start your socket server by listening on a particular port, and it gives you a callback that once the server is up and starts listening on a port, this callback is executed. Now you can configure your server here, that what should happen in case the client is sending some data to the server. So if any client sends a data to the server, you say data is received from the client, and what data has been received, you can mention that here. And then you can actually send some data from the server to the client. You can see when I executed it here, you got the data from the server to the client. So at any point of time, anything you are sending from client to server is received here. And if you have to create a client, then to create a client, there is a method called as create connection, because then now on the available socket server object, you have to start creating new connections, right? So you create a new connection, you mention the port, and you get the client back, right? And you can actually read about the create connection API, right? You can see that here. Okay, so you can see that's also something that we have actually done, right? And then you the moment you connect to the corresponding server socket object, then you are going to print that the client and the server both have connected, and then you send the data from the client to the server. In case server sends something to the client, so you have written an event that on data means when data is received from server to client, then you're going to print something like this. So that's how we have implemented everything here in JavaScript. So socket programming is like very important if you want to actually understand the internals of whatever frameworks and everything you actually use. In real world, when you are setting up things, like, then you don't have to go to so low level network details or so low level APIs, because then your more focus is on building the product that you are focused on. But I believe if, let's say, you land up in a team where you have to actually create your own web framework which creates a server and everything for you, this kind of knowledge is going to be really helpful to you. So I'll just commit all of this, added node code as well. Here we go. So I hope the overall logic of socket programming and how exactly sockets work is clear to everyone. In the further upcoming set of parts, we're also going to start talking about what framework of Node.js, that is Express.js, like how we can use Express.js to set everything up, right? I'll talk few more things around the internals of the application server that is set up by different frameworks. What are some of the low level details, the algorithmic stuff going behind the scenes, and we'll start setting up our brand new servers using Express.js, right? It's going to be pretty simple, like setting up a server in Express.js is simple, and then any client like whatever client you use, like you use a postman creates a socket object internally and set up the connection. All of those things are getting done, but everything is like just abstracted out, so we don't have to bother about it. So we are going to do all of those in the next upcoming set of parts. But I believe this particular whole session around implementation of the sockets and what are sockets is clear to everyone.